far side of the moon has been hiding something for 4.5 billion years. Not a secret in the metaphorical sense, a literal one, a geological truth buried under hundreds of kilometers of rock that no human, no telescope, no spacecraft had ever touched, until China decided to go look. In January 2019, a Chinese lander touched down on the most alien terrain in the inner solar system. And what its instruments found on that surface didn't just surprise scientists. It rewrote the history of the moon itself. This is what they found, and why nobody saw it coming. For all of human history, we have only ever seen one face of the moon, the same craters, the same dark volcanic plains, the Maria, that ancient cultures turned into rabbits and gods and old men. It seemed reasonable to assume the rest of it looked more or less the same. It doesn't. When the Soviet Union sent Lunar 3 behind the moon in 1959 and transmitted back the first photographs of the far side, the scientists receiving those grainy, smeared images went quiet. Where the near side is roughly 31% covered by dark volcanic plains, the far side has almost none, less than 1%. It is an ancient, battered wasteland, craters stacked on craters, ridges and mountain ranges stretching to every horizon, with almost no sign that lava ever flowed there at all. 60 years of orbital photography confirmed what Lunar 3 first glimpsed. The two hemispheres of the same small body are as different as two different worlds. Nobody could fully explain why. That mystery has a name. Scientists call it the Lunar Farside Highlands problem, and it is one of the oldest unsolved questions in planetary science. China didn't just visit it. They brought the tools to start answering it. Here is the problem with the far side of the moon. The moon itself is in the way. The moon is tidally locked to Earth. It rotates at exactly the same rate it orbits us, which means the far side never faces our planet. Not once, not for a single second in 4.5 billion years. That sounds like a minor inconvenience. It is not. It means any spacecraft sitting on the far side surface has 3,400 kilometers of solid rock between it and every antenna on Earth. You cannot call it. You cannot receive its data. You cannot send it commands. The moment it lands, it is, for all practical purposes, unreachable. For decades, this made a far side landing essentially impossible. Not because no one could get there, because no one could control anything once they did. Every space agency on Earth knew the science waiting on that surface. The South Pole Aitken Basin, a crater so vast it stretches 2,500 kilometers across and plunges 8 kilometers deep, was known to be one of the most scientifically valuable sites in the entire solar system. An impact so violent it likely punched through the lunar crust and exposed the mantle below, material from deep inside the moon, sitting on the surface waiting to be picked up. But for 60 years after Lunar 3, nobody landed on the far side. Not the Americans, not the Soviets, not anyone. Then China solved the communications problem. In May 2018, they launched a relay satellite called Queqiao, Magpie Bridge, and parked it at a gravitationally stable point beyond the moon, where it could see both the far side surface and Earth simultaneously. 7 months later, they were ready. January 3rd, 2019, 2:26 UTC. The Chang'e 4 lander crossed the lunar limb, lost contact with Earth, and descended autonomously into von Kármán crater, a 186-kilometer wide basin sitting inside the South Pole Aitken structure, guided only by its own sensors and preloaded software. If something went wrong, there was no one to call. It landed perfectly, and when the Yutu-2 rover rolled onto the surface and the first images came back through the Magpie Bridge relay, mission controllers in Beijing saw something no human had ever seen from the ground. The far side of the moon, up close, in high definition. It looked exactly as brutal as the orbital photographs suggested. Ancient, cratered, completely silent in a way the near side, still wearing the smooth scars of billion-year-old lava floods, is not. The far side wears every wound it has ever received. No volcanic makeover, no resurfacing, just 4.5 billion years of unbroken geological memory. But the real discovery wasn't in the photographs. The Yutu-2 rover carried a visible and near-infrared spectrometer, an instrument that identifies minerals by analyzing how they reflect light. and on the floor of von Kármán crater, it found something the models had not predicted. Olivine, pyroxene, minerals associated not with the lunar crust, but with the mantle, the deep interior layer sitting beneath it. This was the first direct ground-level evidence that the South Pole Aitken impact had done exactly what scientists suspected: punched through the crust and scattered mantle material across the surface. Material that had been locked inside the moon since its formation, now sitting in the open, reachable. It was the first time anyone had touched the moon's insides, but Chang'e 4 was only the beginning. In June 2024, China went further. The Chang'e 6 spacecraft, a fully autonomous sample return mission, descended into the Apollo Basin, also within the South Pole Aitken structure, and spent 2 days on the surface, drilling and scooping nearly 2 kilograms of soil and rock. It loaded the samples into an ascent vehicle, launched back into lunar orbit, docked with a waiting return capsule, and sent everything home to Earth. On June 25, 2024, a capsule parachuted down to the grasslands of Inner Mongolia, carrying the first samples ever collected from the far side of the moon. When scientists analyzed them, the results didn't just confirm existing theories, they complicated them. 108 basalt fragments from the Chang'e 6 samples have now been analyzed, most dated to around 2.8 billion years ago, confirming that volcanic activity on the far side lasted far longer than many models had predicted. The far side wasn't just a dead crater field. It had its own volcanic history, its own internal heat engine, its own timeline, separate from anything the near side can tell us. One fragment dated even earlier, to 4.2 billion years ago. Its chemical signature carried a fingerprint known as creep, potassium, rare earth elements, and phosphorus, a geochemical marker that was thought to be concentrated almost entirely on the near side. Finding it on the far side, in an ancient sample with pristine, unshocked texture, meaning it hadn't been disturbed by an impact since it first cooled, suggests the distribution of radioactive, heat-producing elements inside the early moon was far more complex than any existing model had accounted for. And the younger samples, the ones from 2.8 billion years ago, contained almost none of this creep signature. Something changed in the magma source feeding those eruptions over a span of 1.4 billion years. Something shifted in the moon's interior chemistry, and nobody is entirely sure what or why. We built our entire understanding of the moon from 6 Apollo landing sites and a handful of Soviet sample returns, all of them on the near side. That's like landing in the Sahara Desert 6 times and deciding the entire Earth is made of sand. The far side isn't the dark side. The dark side is a misunderstanding. The far side actually reflects more light because it has almost no dark volcanic rock to absorb it. Pink Floyd didn't help, but more importantly, the far side isn't a dead end. It's the beginning of a completely different story about what the moon is. The moon has been sitting over every human civilization that has ever existed. Every war, every discovery, every night sky that anyone ever looked up at and felt small. And for all that time, 41% of its surface, the older half, the scarred half, the half that remembers things the near side was too hot to preserve, was completely unknown. The Soviets saw it first, through grain and static and stolen CYA film, and named what they could. The Apollo crews flew over it in silence, cut off from Earth for 45 minutes every orbit, alone with a landscape no human had ever stood on. China landed on it, and brought pieces of it home. Chang'e 7 is heading to the lunar South Pole in 2026. Chang'e 8 will follow in 2028, testing technologies for a permanent research station. The silence that kept that hemisphere locked away for 4.5 billion years is finally breaking. Whatever the moon has been keeping to itself, about its own formation, about the violent early history of the solar system, about what's sitting inside it, we are, right now, in the first few pages of actually finding out. So here's what I want to know. The far side samples contain chemistry that doesn't match our models. A chemical fingerprint we thought was locked to the near side, sitting in ancient, pristine rock on the wrong hemisphere. If you were designing the next mission, what would you go looking for? Drop your answer in the comments. I read all of them. And if you want to understand why the far side's radio silence makes it the most valuable astronomy platform in the solar system, a place where we could listen for signals from the universe's first few 100 million years, that's the next video. It's up now.